inverse trigonometric functions and their graphs. Recall that in order to have an inverse of any function, a function must first be one-to-one. So if we want to take the inverse of the sine function, for example, the sine function is not a one-to-one function. Remember, to be a one-to-one function, when you draw a horizontal line, it can only hit the graph one time. But of course, when you draw a horizontal line across the sine function, it hits the graph many, many, many times. So what we have to do is we need to make this function one-to-one. And the way we do that is by restricting the domain. So if you notice this little piece of the graph that is in red here, if we only have that piece of the graph, this is now a one-to-one function because every horizontal line that I draw will only intersect this graph one time. So to make the sine function one-to-one, we restrict the domain of the sine function to be between negative pi over 2 and positive pi over 2. So in doing this, the domain of the sine function is all values of x between negative pi over 2 and positive pi over 2. And the range of the sine function is all values of x between negative 1 and positive 1. So with this, we can now define the inverse sine function, which is denoted sine with a little negative 1 up here. And it will have a domain of all values between negative 1 and positive 1, and a range of all values between negative pi over 2 and positive pi over 2. And we define y equals the inverse sine of x, to mean x equals the sine of y. The inverse sine function is also called the arc sine function and is sometimes denoted by arc sine. So for example, we can either use the notation inverse sine of x, or we can use the notation arc sine of x. One of the things about the inverse function, of course, is that when you take a function of its inverse function, those will cancel each other out. So sine of inverse sine of x will equal x, but this will only happen if x is in the appropriate domain. So x has to be in between negative 1 and 1. And likewise, the inverse sine of x will equal x, but x has to be in between pi over 2 and negative pi over 2 for this to be true. Now, the inverse graph is basically going to be this graph with the x and y coordinates switched. And so when you switch the x and y coordinates, you get the inverse sine graph, which is this graph here. Now to evaluate the inverse sine function, this is pretty much just knowing your special values. So for example, when we say the inverse sine of 1/2 is equal to some value, let's say y, what we have to recall is the meaning of this is that sine of y would be equal to 1/2. And so you would have to ask yourself, what is the value such that sine of that value would equal 1/2? Of course, there are many values here, but the one that is in the domain of the sine function for which the inverse is defined would have to be y equals pi over 6. So in other words, we know that sine of pi over 6 is 1/2. We also know that pi over 6 is a value in between negative pi over 2 and positive pi over 2. Therefore, the inverse sine of 1/2 would simply be pi over 6. For the next one, we have the inverse sine of negative 1/2. So inverse sine of negative 1/2, if I set that equal to some y value, that means that sine of y would have to be equal to negative 1/2. And this is basically the same process, but if I have to pick a y value, and that y value must be between negative pi over 2 and positive pi over 2, such that sine of that value equals negative 1/2, then we know that y would have to be equal to negative pi over 6. Because negative pi over 6 is an angle in the fourth quadrant, and the sine of negative pi over 6 is negative 1/2. So in this case, it is negative pi over 6. And finally, the inverse sine of 3/2. So if we have inverse sine of 3/2, if it's equal to some y value, this would have to mean that sine of y is equal to 3/2. However, this is not possible because we know that anytime we take the sine of any angle, we always get a number in between 1 and -1. And since 3/2 is not in between 1 and -1, in other words, 3/2 is greater than 1, this is not possible. So basically here we have does not exist. Now, if you're not given a special value for which you already know the angle, for example, if you're given the inverse sine of 0.82 or the inverse sine of 1/3, 0.82 and 1/3 are not known special values of the sine function. And so in this case, we have to make sure to use a calculator, and we need to put that calculator in radian mode. Otherwise, it's going to give you an angle in degrees. So let's go ahead and take the inverse sine of 0.82 and the inverse sine of 1/3 on a calculator, and we'll display those results. And usually what we do here is give a 4 decimal place approximation. So I would write the inverse sine of 0.82 is approximately equal to 0.9614, and the inverse sine of 1/3 is approximately equal to 0.3398. Next, recall the inverse function property, which says that sine of inverse sine of x equals x, and inverse sine of sine of x is equal to x. But again, these functions only cancel each other out if x is in the appropriate domain. Okay? So for example, inverse sine of pi over 3 is equal to pi over 3 as long as pi over 3 is a value in between negative pi over 2 and positive pi over 2. So keep in mind that negative pi over 2 is this angle down here. Positive pi over 2 is this angle up here. And so pi over 3, of course, we know is right about here. It's in the first quadrant. And so indeed, pi over 3 is a value in between negative pi over 2 and positive pi over 2. Therefore, the inverse sine of the sine of pi over 3 is just going to equal pi over 3. Now, for the second one, we have the inverse sine of the sine of 2 pi over 3. But if you look at 2 pi over 3 as an angle, remember, of course, pi over 2 is here, negative pi over 2 is here, so we need that angle to be in between there to cancel. But 2 pi over 3 is over here. Okay, so the inverse sine of the sine of 2 pi over 3 is not 2 pi over 3. In other words, these do not cancel out. All right, so what does that mean? Does that mean that we can't do it? Well, no. What it means is that we have to work this out from the inside out. So, for example, if I have inverse sine of the sine of 2 pi over 3, what I can do is I can figure out what is the sine of 2 pi over 3. And so if we go to our unit circle, the sine of 2 pi over 3 is radical 3 over 2. And now this just becomes the inverse sine of radical 3 over 2. And then if you look for the angle that is between negative pi over 2 and positive pi over 2, for which sine has a value of radical 3 over 2, that angle is now going to be pi over 3. So notice that they do not cancel each other out, but you are still able to compute it. You just have to start on the inside, figure out that value, and then work on the outside function. The inverse of the cosine function works very similarly. So the cosine graph, of course, it's very similar to the sine graph. It is not a one-to-one function. However, if we focus on the piece of the cosine function from this point down to this point, you can see that that section of the graph is one-to-one. So we are looking at the function y equals cosine of x, where x is allowed to be between 0 and pi. The range, of course, would be all values between -1 and +1. And when we restrict ourselves to that piece of the cosine graph, we can define the inverse of the cosine function, denoted inverse cosine, and it will have the domain -1 to +1, and the range, of course, will be from 0 to pi. and it is defined by y equals inverse cosine of x if and only if the cosine of y is equal to x. And just like with sine, we can also call this the arc cosine function. So the notation is we can say inverse cosine of x, or we can say arc cosine of x. And it has the same inverse function properties. So if we take the cosine of the inverse cosine of x, we will get x as long as x is a number in between -1 and 1. And if we take the inverse cosine of the cosine of x, we will also get x if x is between 0 and pi. Okay, so it's a little bit different for sine and cosine. Remember, for the inverse sine to cancel out with sine, this had to be between -pi/2 and +pi/2. But for cosine, we're looking at a different domain in the beginning. That is why this has to be in between 0 and pi. And of course, the graph of the inverse of this function, you can get that by just interchanging the x and y coordinates, and that graph is going to look like this. So for example, if I want the inverse cosine of radical 3 over 2, we need to think, well, if inverse cosine of radical 3 over 2 is equal to some y value, this means that cosine of y would have to equal radical 3 over 2. And of course, y has to be an angle in between 0 and pi. So what is the angle for which cosine is equal to radical 3 over 2? We should know that y must be equal to pi over 6 in this case. And so the answer here is pi over 6. And again, that's because this is a special value. Inverse cosine of 0, this works very similarly. So if inverse cosine of 0 is equal to y, this means that cosine of y is equal to 0. And once again, the value of y has to be in between 0 and pi. So what is the angle between 0 and pi for which cosine is 0? Well, we should know that angle is pi over 2. So the answer here would be pi over 2. And finally here, if we have the inverse cosine of -1/2, if that's equal to some value y, the meaning here is that cosine of y would have to equal -1/2. And then on the unit circle, where is the y value between 0 and pi? And again, y in this case is an angle. What is the angle for which cosine equals -1/2? Well, that y value would be 2 pi over 3. Okay, you can double check all these by looking at the unit circle here, but that means the answer in this case would be 2 pi over 3. Now, just like with the sine function, if I have inverse cosine of a cosine, we would like for these to cancel out, right? And in fact, that is what happens here as long as this x value is between 0 and pi. So really the question here is, where is 2 pi over 3? Is it between 0 and pi? And the answer is, of course, yes. This is 0, this is pi. Angles between 0 and pi would be angles in here. And we know that 2 pi over 3 is right about here. And so in this case, they do cancel each other out. And the answer here is just 2 pi over 3. For the second one, it's the same thing. We would like for these to cancel out here, but because 5 pi over 3 is not an angle between 0 and pi, they are not going to cancel out. So again, inverse cosine and cosine will cancel out if the angle here is between 0 and pi. But 5 pi over 3 is an angle in the fourth quadrant. So to do this problem, we have to start on the inside of this expression and work our way out. So we have inverse cosine of the cosine of 5 pi over 3. Cosine of 5 pi over 3, if you look at the unit circle, we'll find that this is equal to 1/2. And so now this simply becomes the inverse cosine of 1/2. And so now we want to know, what is the angle whose cosine is equal to 1/2, and that angle has to be between 0 and pi. So we know since this is positive, that has to happen in the first quadrant here. And of course, the corresponding angle would be pi over 3. So the answer here is pi over 3. And finally, we have the definition of the inverse tangent function. Now, one nice thing about tangent is if you look at the main part of y equals tangent of x, so the part that's between negative pi over 2 and positive pi over 2, this piece of the tangent graph is 1-to-1. So as long as we ignore these other pieces out here, we have a 1-to-1 function. So that means that we're going to look at y equals tangent of x on the domain from negative pi over 2 to positive pi over 2. For that section of the graph, we can define the inverse tangent, and notice that the inverse tangent graph is sort of like a sideways version of this tangent graph. And we define the inverse tangent function to be tangent with a little -1 here. Domain is going to be all values between negative pi over 2 and positive pi over 2, and the range will be -infinity to infinity. And of course, we can use inverse tangent or we can use arc tangent. So we can either write inverse tangent of x or we can write arc tangent of x. These have the same meaning. And finally, of course, tangent of inverse tangent will cancel out as long as x is in the appropriate domain. And for inverse tangent, that can be any real number. And then tangent of inverse tangent of tangent will cancel out as long as x is an angle between negative pi over 2 and positive pi over 2. So for example, if I want to find the inverse tangent of 1, this is equal to some y value, let's say. That means that tangent of y would be equal to 1. So I need to know what is the angle between negative pi over 2 and positive pi over 2 that has a tangent equal to 1. And we should know that that angle is pi over 4 because we should know that tangent of pi over 4 is 1. So in this case, the answer here is pi over 4. Inverse tangent of radical 3, if that's equal to some value y, that would mean that tangent of y is equal to radical 3. And once again, we would need to be looking for the angle between negative pi over 2 and positive pi over 2 for which tangent is equal to radical 3. So if you know this, you would know that this would be the angle pi over 3 because tangent of pi over 3 is radical 3. So the answer here is pi over 3. And finally, if I want the inverse tangent of 20, if this is equal to some y value, that means tangent of y equals 20. But of course, 20 is not a special value. So if I want to take the inverse tangent of 20, I would simply use a calculator to do that. And in this case, this would be approximately 1.5208. Now, it is possible to define inverse secant, inverse cosecant, and inverse cotangent. And here are those functions, their restricted domains, and the graphs of those inverse functions. But I will just tell you from experience, there is no need to memorize these graphs or these domains. We can pretty much do everything that we need to do, for the most part, with inverse sine, inverse cosine, and inverse tangent. And that concludes this video lesson.